In my opinion, the permutation formula is unnecessarily confusing. So here we can see that it's essentially made up of multiple factorials, multiplication, and division. Now, in order to explain why I think it's confusing, we first have to think about what the situation that we're actually trying to model is. So with permutations, permutations always answer the question, how many different ways can I fill R spots with N options? So in this case, we can think about a race where we have 5 different runners running the race. So the different runners are our different options. In this case, we have 5 of them. And then we can think about first, second, or third place as the spots that we're filling. So that would R would equal 3 in this case. And you could try to think about how we could do this by just listing out possibilities or guessing and checking, or maybe thinking through it a little more systematically. Like, for example, you could have person 1 come in first place, person 3 come in second place, and person 2 come in third place. Or you can swap people around. It really just depends. So there are many different possibilities that we can think of here, and in general, it's sort of hard to come up with them. So, for example, we could have 1, 2, 3. Person 1 in first place, person 2 in second place, person 3 in third place, and we have a whole bunch of other possibilities that I've listed out right here. And there are many more than this actually. So this is only some of them, and it's hard to think through all these cases in general. So what we want is we want a way to think about it a little bit more systematically. And here we're going to look at it a little bit different. So instead of trying to list out the possibilities for how many people or who can go where and trying to think through all the separate cases, because that gets a lot harder as you have more options. So if you have like 10 or even 100 options, there's just a massive number of cases that you would have to think about. So that's really not going to work for us. We need a way to think about it differently. So instead of thinking through the cases for which specific person goes in which spot, we can instead think about how many possibilities there are for each spot. So for example, if we have 5 options and we're trying to fill them in just one spot, so forget about spots 2 and 3, but we're just trying to fill them into one spot, well, clearly we have 5 possibilities there. And in the second case, after we've already chosen somebody for first place, so that's the key fact, after we've already chosen someone for first place, how many other options do we have left over for second place? Well, 5 minus 1, which would be 4. And then after we've already chosen, somebody for first place and somebody for second place, depending on who, it doesn't matter who we chose, but we'll have 3 people left over. So we have 3 possibilities for who could come in third place. And in general, if there are 5 different possibilities for first place, for every 5 possibilities there are for first place, there are 4 separate possibilities for second, and then for each of those, there are 3 separate for third. So the way to think about this is that we should multiply them all together. So if we multiply 5 times 4 times 3, then that would equal 60, and that is the correct answer in this case. So in this case, there actually are 60 possibilities to think of, which is a lot, maybe more than you would think. Now, the way that we would calculate this with the permutation formula, so remember our permutation formula, if we have n possibilities and we're trying to fill r spots, then the formula for our permutations looks like this. So n minus r factorial. And if we listed this out, remember n is 5, that's the number of runners that we have, and r is 3, that's the number of spots we have, so first, second, third place. Then if we listed those out, we would have 5 factorial divided by 5 minus 3 factorial. And then if we list out down here, factorial means that you basically start at that number and keep multiplying it by numbers that are 1 less than that. So 5 factorial, until you get down to 1. So 5 factorial will be 5 times 4 times 3 times 2 times 1. And then 5 minus 3 would be 2. And then 2 factorial would just be 2 times 1. Now here, the way the permutation formula tries to explain this situation is that we're basically starting at 5 in the numerator and then counting down all the way to 1. And then in the denominator, we start at 2 and count down all the way to 1. So what's really going to happen is that the 2 and 1 in the numerator will be canceled out by the 2 and the 1 in the denominator. And you can see that we're going to be left with 5 times 4 times 3, just like we were in the first case. So we still get the right answer with the permutation formula. It still makes sense, but I think it's unnecessarily complicated. We don't actually have to think about a gigantic number in the numerator or denominator because most of the things are going to cancel out anyway. In my opinion, it's easier to just start at the number of options you have and multiply that by numbers that are one less than it our number of times. So, for example, in this case, we have 5 runners, so we start at the number 5, and then we multiply it by numbers that are 1 less than it for a total of 3 times because we're trying to fill 3 spots. We get the same thing either way. So, this is the way that I prefer to look at it. And if you understand this way of looking at things, then I think the combination formula, which is a slight change on the permutation formula, also makes sense. So be sure to stick around for the next video where we go over that.